if these two things, if the gap between them are what are you, what is it telling us? We are fitting. So right for the other one, he said underfitting, of course, when the model is not able to obtain sufficiently low error value. This is how I'm going to explain this stuff. I don't want to use this one, but say that the upper model is supposed to like go down like this. This is your optimal. But your model, your underfitted model is like it will just come, it will go like this. It's not what? Of course, when the model is not able to obtain a sufficiently low value, it's not able to obtain a sufficiently low value. You know that this is from, we don't even know what this value is, but this is 0. You can go as high as it wants to be, but this is 0. So you can see the distance. This is your optimal model. This is your underfitted model. So when it is not able to sufficiently give you low value, that means that model has what? Underfitted. Yeah, you guys have to like understand this. This is like the most important. If you're not understanding it, it's like today is a waste. So I want you to understand it. Underfitting is what? Let's read it together. Underfitting, okay, somebody should just read me, but my voice is not that clear. So
underfitting occurs when the model is not able to obtain a sufficiently low error value for the training set.
okay. So this is the model. This is the underfitted model. Let me put a value to it. Let's say this is 0, this is 10, this is 1. Right? This is 10, this is 1, this is 10, right? For the underfitted model, what is it giving us? The error is giving us 10, right? For the optimal model, the error is giving us what? 1, right? So it is, the model is not robust enough to go down. So that is why it is giving us 10. You get? Why for the one with the actual model is supposed to give us 1. It is giving us 1. So it is underfitting in this situation because it's the model, irrespective, if you increase the training exam, it's still not going to go down. That is its limitation, that is the capacity. So you can continue.
Overfitting occurs when the gap between the training error and the test error is too large.
So this is your VC. Let's not use VC, let's call it test. This is your what? Your train. Right? So can you read it again?
Overfitting occurs when the gap between the training error
This is your training error,
okay,
and this is what?
And the test error.
This is your test error.
It's too large.
This is too large.
Yes.
You understand?
Okay.
So hope you all understand this now. So if you want to know about this, you read chapter 5 of the book, then you are good to go.
Well, you put it in the book.
Yeah, it's online. It's online. It's free online. So we are going to talk about regularization. So can someone define regularization or just explain regularization? I know I've asked him, so he said it. So with respect to people in you, so what is regularization, if you can remember? Also, do you want someone else?
Let somebody else do it.
Yeah, someone from the back should give us a brief intro on regularization.
Regularization is when you try to protect your model from fixing.
Yeah, it's right. So, and what is ladder?
Is the regularization
Parameter. Okay, you are right. So regularization is a process whereby you penalize your model to penalize your model, that means let's say your higher order functions, you try to like bring them down to from being a complex function, you bring them down to a simple function. That is what regularization is. So you are penalizing your models in such a way that they will not overfit. That is the point of regularization. So, and you do that by bringing in your regularizer. This is your regularization function. What it does is that it adds I values to your model parameter. So what is this? This is what I'm talking about. Let's say what I'm talking about. For I bias, so in this situation you have underfit. Why is this stuff underfit?
The error is doing. The error is
From what we are seeing, why is it bias? Why is it high bias?
The model does not fit the data. It's not touching any point.
The model does not fit the data. The model is just there, and the data is there. So this is the model. This is the data. You understand? Right, for this one, why is it high variance? I keep asking this stuff over. It's not about. I want a situation. I want you to all understand it, because you keep saying this stuff, and if you don't understand it now, you won't understand it again. It's overfit because
it's fitting all the points.
okay, but this is what we want. So this is how you solve the problem. If you have I bias, what you do is that you increase your lambda, which is your regularizer. You increase it. You do it in such a way that, let's say you increase lambda. If you increase lambda, this guy will go up, this guy will go up, I'm sure that one will go up. All these ones will go up, leaving you with just these two. When you increase your lambda. That's how you solve this problem. If you're having high variance, what you do is that, it's like I'm mixing it up. If you're having high variance, what you do, when you talk about high variance, that means your model is overfitting, right? What are you going to do? You want your model to, from complex function to simple function. So what you do is that, let's assume this is what do you call that function again? Quartic. You want to bring it down to a linear model. What are you going to do? You knock this guy out, right? You knock this guy out. You knock this one, leaving you with these two, right? So that is what you do, that when you say your lambda is equals to 0. So what your lambda basically do that it knocks some of these what do you call it, model parameters off, leaving you with simpler model. That is what it does. Right, for this one, you increase your model parameter. It adds more model parameter to make your model more robust. What I said, it doesn't make any sense. You have a simple model. It's not generalizing. When you make it robust by adding more parameters, you have a robust system. It's overfitting. You want to make it simple. You do what? You remove some of them to make it simple. You want them to be such a way that they will be just like the perfect model. This slide, you understand it, right? Okay. So how do you do that? Choosing the regularization parameter, how do you do that? So the first thing you do is that you get your J-train, your JC, and your J-test without lambda. So we all know what this one is. We all know what J-train is. We all know what JC, we know what J-test is. You understand it, right? Fine. So we obtain this value without lambda. Lambda is what? Your regularization parameter. You do that without, you try to do your normal stuff without lambda. Then when you do that, the second slide, when you do that, you get the lowest error on the validation set. Because you know that the validation set is like the most important thing here, since we are splitting the data into 3 points. So when you get the lowest error in the validation set, but before we get to that point, this time around, we will start adjusting our lambda. First thing we do, you try lambda, y is equals to 0. That is like, you don't have any lambda. We don't have any value there. Then you step up 0.01, then 0.0. You try different lambdas. But it says something about you try lambda from 0 to 10.24. That's like the range in which you're going to try your lambda. So by doing that, you get the error for each and every one of those lambdas that you have tried. Then after doing that, let's assume that this fifth model is the one that gave you the lowest error. Let's assume that's the one that gave us the lowest error on the validation set, on the cross validation set. Then you use that one, you test it, you run it through your test sets. What I said, it doesn't make any sense. So the first step is what? You outline your lambda, then you do what? You train, then after training, you try to get the minimum in your cross validation sets. With that, let's assume that this is the one that will give us the lowest. What are you going to do with this one? What are you going to do with this one?
Use it on the test set.
You use it to test. Make sense?
Test error.
Okay, that's it. Use the model parameter on the test. That is what you will do, yeah?
Sorry, question. Is there any reason why the lambda is capped at 10.24?
I don't know. He just said that he prefers using lambda from the range of 0 to 10.24. That's what he said. I don't know. You can increase it if you want to. So, by doing that, okay, we get our test. So after once we obtain our model parameter, what we can do is that we can use it to plot this graph of lambda versus your error. When you plot this graph, this is what let's assume this is what you get. But now you want to know what is the perfect lambda. That is what you want to know because you have tried different range of lambda from 0 to 10.24. You want to know the perfect lambda. So for you to get the perfect lambda, you're going to get the point from which this is your validation loss starts increasing. What I said doesn't make any sense. The point from in which your cross validation error increases.
Yes.
Then the first one is what? Like this, the second one is like this. Then this is lambda versus j theta. This is for your train, right? So this is the optimum lambda. This is the part we want. From this point, what can we say from this point? What is happening from this point? It starts increasing. You understand? So this will give you the perfect lambda. Yeah. From this point here, it starts increasing. So this is the lambda you're going to use. That's your model, your regularizer parameter. Your regularizer value, not parameter again. So from there, we're going to talk about learning curve. So what learning curve is basically saying is you will do artificial. Is there any problem? Okay. Artificially restricting the size of the training set. Meaning, you assume that you reduce your, not even, it's not an assumption, you reduce your training sets. You say, let it just be X, let it just be one training set. You try to fit a model through it. That's the first one. You bring in another training set, you increase it 2, 3, 4, let's say 5 and other. The more you increase your training set. So you try to, like, as you're increasing your training set, you try to know what model will fit that training. As it is increasing, what model will fit as it increases. So that is what we are just trying to. That is what learning curve is all about. So you increase your training set, you get the model that will fit it while it is increasing.
Can I ask a question, please?
Understand?
This your M1, M2 up to M4, the training set. Is it I'm going to cut maybe 30% the red one, that one, M2 and all that?
It's going to be like, let's say you start with 20%,
Okay.
then 30%, you keep 40, 15.
Another question, please. The CV, the course validation, is it the normal validation as in maybe you said 80, 20, 20, so 60, 20. Is it that 20 that is the CV?
Yeah.
Okay. Because there's the way some people do their own CV. So I just want to clear.
Any other question? The class is boring. Someone is already sleeping, so. The class is boring. You want to start it? Okay, don't worry, man. We'll finish very soon. So, I bias. If the learning algorithm is suffering from I bias, getting more training data will not help much. So what are we saying? You know, we are doing we are using learning curve, right? And what is learning curve all about? What's learning curve all about?
Showing us how our model is.
Okay, we are increasing the number of training sets. So by increasing the number of training sets, if you have I bias, increasing the number of training sets is not going to help your situation. This is with few training sets. This is with much training sets. So your model is still where it is. Increasing it is not going to help your situation. So that when you have a model with I bias, increasing the training set is not going to solve the problem. That is what this slide is all about. And how do you know your model is having I bias? It's when the what? And what?
And the train error is low.
Close. Close. But you know that, okay, if your training set is good, okay, if your cross validation is okay, if your cross validation error is low, it's going to come down, right? That means if it comes down, that means this guy is not even going to be like this. Probably it's going to be like coming down like this. Both of them is going to like, how am I supposed to explain? So basically, this guy is supposed not to be too close to this guy. That's what I'm trying to say. The gap between them should not be that close. So if you have I variance, so what are we talking about? This is your, with few data sets, with more data sets. What can we see here?
Perfect.
But is it just, is there no change in the model?
There is.
There's a change.
Yeah, you just cramming the points.
But there is a change. That's the most important thing I want to say. So the fact there is a change to the model, it means that the model is trying to adjust itself. So the more you increase the data set, probably it's going to adjust itself in such a way that it's going to generalize, right?
Yeah.
So if your learning algorithm is suffering from I variance, getting more training sets is likely to help. Why?
It's better to fit it.
Keep learning and adjusting.
And because we are increasing the so you understand this slide, right?
Mm-hmm.
So far so good. We have discussed I variance, I bias, different stuff. So get more training example. What problem is he going to fix?
High variance.
So how? Can you explain how?
Because it continues to change.
Okay. Okay. You understand what he said now, right?
As you increase the number of training sets, the model
You don't understand. Can you repeat what you just said now?
So as we increase the number of training sets, the model tends to learn to
Okay.
Now, how does the model actually change? I think is it not you that you actually training that? I mean, that's going to change the model parameter to ensure the model change and follow the sample.
I don't understand what you just said.
The model, we understand that for high variance, what you just said, for high variance, the increased number of training sets, the model tries to change itself, adjust itself to ensure that it links better, to the generalization. So my question will now be that the model that's changing, does it just change by itself, or we are the one that keeps changing the model parameters to make sure the model changes?
The model changes by itself.
Model changes by
Using
using
smart enough.
stochastic gradient descent. You are doing that class, right? Okay, so with that, that is your learning algorithm. You understand? So your learning algorithm is what is your packet model parameter. You understand? Just answer the question, right? So trying additional feature. Why do you try additional feature? What problem is it going to solve?
So high bias.
High bias.
I know it's high bias. You are saying high bias.
That high bias implies underfitting.
Yeah.
And increasing the number of features now will give it more, make the what's it called,
More robust. So yeah, that's right. Adding polynomial features to fix what?
high bias.
How?
Is it not the same thing?
High bias might have a
This one is adding features. This one is adding polynomial features.
You know, when you increase the polynomial,
The order, the degree of polynomial increases. That's what this guy is talking about.
and that's,
So
that's shoots up
that's low.
no, sorry, I'm not saying
By adding more, I'm not just talking about complex. You're making it more robust.
it's still the same
They're making it more robust. So decreasing the what is this again? What will it do?
try decreasing.
How?
It will try to introduce higher order of degrees to the algorithm that tends to fit more and reduce the bias.
Let me go back to that slide. This one. I'm sure you have not passed this slide.
Fast it.
Is it? I don't even know.
This it.
Not
The-
this is
The next one.
the slide is okay. This is here. So high bias, right?
Mm-hmm.
How do you solve the problem?
To increase the lambda.
Increase what? Let's say what is high bias first of all. What's high bias? You have simple
You have
model.
simple model.
You want to make it more robust. What do?
You increase the order
You increase the order by doing what?
by introducing.
This is the guidance you will change. You make it. You increase the number. When you increase the number of your regularizer, you should make it big. It's going to increase the complexity. So thereby making it something robust. If it's low, if your variance is too high, if your variance is high, that means you have a complex model. You want to what?
Reduce it.
Reduce it by doing what?
By
Zero.
Zero. So you understand that, right? So we've talked about this too, and this is just like the basic guideline you have to follow when you are troubleshooting your model. So we're going to talk about regularization, training practice, and the regularization with respect to neural network, the best practice with respect to neural network. First of all, let's talk about neural network. So, someone should, yeah, we did revision last week, so let's just have like a 1 minute or 30 seconds talk on neural network. Anyone can talk. You can start from the history. You can talk about anything. For people that are just coming for, how many of us are coming for the first time? So let's just educate our first timers. So let's talk about neural network. People know this stuff now. We did revision last week now, so oh yeah, now let's do it now. Someone should okay. Let's make it fast. Okay.
Yeah, I think neural networks is an algorithm that uses the way the brain processes information, which are neurons, dendrites, and axons. So I think the dendrites is the input unit, then it goes through the neuron, then it outputs it from an axon. So we try to model that using algorithms, having input layer, hidden layer, and output unit. So I think the input layer is basically based on the number of features that you have. The output layer is basically based on what you want to predict. If you're predicting binary classification, if you have like one output layer, there's more than that multi-class classification based on the number of labels that you have.
Okay.
And the hidden layer is arbitrary. I think it's based on, the higher the number of hidden layers you have, the more, I think your computation, the higher the cost of computation that you pay. So that's what neural network is. Each layer computes a sigmoid function. So it's just like each layer computes a sigmoid function, then the output layer
It's been fed to another.
So each layer computes a sigmoid function, passes that computes something, passes it to the next layer.
Yeah.
That one computes it and gets the next layer. So you get to the output where you need to make the prediction.
Thank you very much. Can you clap for it? So, just like what he said, you are trying to, this is just a function, they call it universal function approximator. Just like your brain is a universal function approximator. You can use your brain to solve any complex problem, provided you are willing to solve that. So, my point being that this is what neural network is all about, is mimicking the brain, how the brain functions. So, it takes a problem in, looks for how the pattern behind it, then solves the problem. And that's what neural network for layman, that I'm going to explain here. But you guys know better. You have any question? We all understand it's like yes or no? Yes. Yeah, so now, neural network and overfitting. So, this is what? Okay, first of all, what is one unit of this? What do we call it?
Single layer.
Just one.
Hidden layer.
Neuron. What is the other? Is a neuron with respect to the human brain? What's the like? I know it's not
Hidden layer.
What's your other? What do you call it again? Perceptron. Thank you very much. So it's perceptron. When you stack perceptron up, you have a layer. Then what do we call that?
Hidden layer.
Yeah, we call it multi-layer perceptron. This is a multi-layer perceptron. This is a multi. When you stack them and you have depth, what do we call it? Deep what? Deep neural network. So difference between this guy and this guy is just first of all, difference between this guy and this guy is what? The depth of what do you call it?
The depth of the perception.
Let's not use depth. Let's
The
just avoid all
number.
those fancy
The
words.
number.
Fancy name. What's the difference? The
Number of
number of perceptrons, logistic, number of perceptrons in that layer is much. So we assume that this one is more robust than this one, right? So when you start them up, you become more. So the logic there is that this guy is computationally cheaper than this one. This one is computationally expensive because at each point you have computation. to get the output, you just have to like run it through this layer to get the output. While for this one, you have to like run it through this guy, before you get your output. But by doing that, this guy is more robust than this guy. Use this guy for solving complex problem. They use this one for solving basic problems, though. So my point there is that how are you going to know that your model is overfitting? How are you going to know with respect to neural network? How are you going to know? How? Okay, with respect to linear regression, how are you going to know? Like the very first slide, the very first two slides, I said something like, how are you going to know? If you know that it's
When it says error, it's loss.
so you can tell for this guy, but you can't tell for this guy. You can visualize this one, right? Because it's a simple model. When you have multiple features, how are you going to visualize for that? You can't. So since you can't, what we have done so far is to know how to solve overfitting, even when we cannot visualize. What I said, does it make any sense?
Yes.
So what we have been doing so far is a situation whereby you don't have the privilege of visualizing. This is how you're going to solve it. I needed to ask that question so you know. I want to know whether you guys really understand what we are doing so far. But yeah, you guys are right. So far, the answer you gave me was right. We'll stop that slide. Almost today is fast. So small neural network, they have fewer parameters and they are more prone to underfitting because they are not robust. You understand this statement, right?
Yes.
They are not. This is just like, let's assume this is like linear model. This is polynomial model. Let's assume. But we call them higher, is a function approximator, so a complex function approximator. So this one can just approximate, let's say it can just approximate second degree polynomial, which is a quadratic. This one can approximate like to d infinity or to d infinity. Yeah, it's possible. You stack them, you can do that. So my point that this one are prone to overfitting. Why this one are prone to what? Overfitting. And how do we address that?
Regularization.
Thank you. So this is your number of epoch versus your loss. You want to know whether your model is overfitting or underfitting with respect to neural network. So the first thing you do is that you split your data into what? Your train, validation, and test sets. You keep 30% to 30% of your data for validation, but let's just stick with 20. So you fit the model parameter on your train set using this. That's the question. That's the answer.
So I'm just thinking, like that place where you have
This one.
yeah, for a complex model. So I'm just thinking, you know, in a real life scenario, when you have something like this, when you run this kind of model, usually it's going to be very slow.
Yes, computational.
So what do you do to make it faster? Assuming you are,
If they say the model is what you the work you are, the problem you're solving is complex,
Yeah.
and you need complex, and you need a big model, right?
so you know, after you build your model, you're going to deploy it to the front and you have to use it. And every time you have to run it. To take more system time and everything. So what do we do to make it less expensive also? Or make it run faster or how to do that.
Okay, let me, based on what I know, let me try and answer this question. Training this stuff might be computationally expensive, but your inference is always fast. What I said doesn't make any sense. The results you are going to get is usually fast.
It's fast.
Because at the end of that training, you are going to have like a model. So it's all about API that will
Just
send,
feed them.
gives you your output. So anything, the speed is not with respect to the model, it's with respect to the architecture, what you are dealing with, probably your network or your infrastructure. Answer. So, we've done this. Then after each epoch, you test your model on the validation set, compute the loss. Also, compute the loss of the other metric. Let's do this one. Snapchat, it's not part of the model. So you plot your learning curve as training progresses, which is what we are doing here. You stop your validation loss. You stop when your validation loss starts to what? Increase. Which is which point? This point. As it's increasing, that's when you should stop. Then use the model with the minimum validation loss. We all know this part now.
Mm-hmm.
It's an assumption. We all know this part, right?
Yes.
If you don't understand it, you can just, we all understand this part, right? Okay, which part is it that you don't understand? Which number?
From
Okay, from 2. Fit model parameter on your train set using XGD. Stochastic gradient descent. What's stochastic gradient descent? You know what stochastic gradient descent is, right? Huh? Yeah. Okay. So what part of it is that you don't understand? You train, this is what I'm talking about. We train with our train sets. That's what we're talking about here. Then each epoch, each process, you plot your, this is just, at each epoch, you test your model on the validation set. You know what validation set is? Then you compute your loss. Normal. Then let's skip all these parts. You plot your learning curve as training progress. As training progresses, this is what we are doing here. Then you stop when validation loss starts to increase. If this stuff starts to go up, you stop here. This is where you should stop. Use the model with minimum validation loss. You understand, right? So you have overfitting for your neural network. Your validation loss decreases at first and starts to increase. Fine, that is what is happening here. Your training loss increases. Your training loss continues to go down. Your training loss is going down. Now, based on what we have said so far, how are you going to solve this problem for overfitting? Can you help? Hello? So for this question now, how are you going to solve it? I'm talking to you. Yeah. For this question now, how are you going to solve it? You. Yeah. This one. How are you going to solve the problem of overfitting? Someone else can give it a try.
Find more training with data sets.
You want to, and if you should remember from what we discussed like a few slides ago, when you have overfitting, if you should increase more data, say what will happen? Data point, what will happen? It makes it more robust. So find more training data. That's what you use to solve this problem. You find more training data. You add strong regularization. We're going to discuss about dropouts. L2, no, I don't know. Talk about, okay, data augmentation, reduce the complexity of the model. It's overfitting. So you have to reduce the complexity of the model by using regularization. So first of all, let me talk about dropout. You have a slide for dropout. Let me talk about data augmentation. So sometimes, currently we are all working with the MNES data sets, right?
Question please, when we are reducing the complexity, you know the lambda finally will be 0. Do we gradually reduce the value? Try it, try it again, lower to get 0. Or just put 0 straight.
Your lambda is varying.
That's what I'm saying. Am I the one to be changing it gradually, decreasing it?
I said you are going to try lambda from 0 to 10.24.
So when we're trying to decrease the complexity, I'm asking, finally the lambda should be 0. I'm saying when I'm decreasing the value,
Finally, the lambda should be 0.
do I change in graduation or I should just put 0?
From the slide, it showed us that when we have high bias, our lambda, we have to increase our lambda to increase complexity,
Yes.
so that the linear line fits the curve. But when we have complex orders, so we have to decrease the complexity by
Okay, you say, you just put 0?
Exactly.
No, you just try to
Got that
right.
gradually. I just wanted to know the right path.
No, you can't just put 0 like that. Okay, data, so far so good. You guys have been doing MS. How many of us are doing the exercise? There's no people that will be going home early today. So. How many of us are doing it? Let's be truthful. Let's be honest. You're going to church tomorrow. How many of us are doing it? How many of us are doing it?
I'm on it.
You're on it. You're not doing
I
it.
started, but I'm not
Okay,
finished.
you have started. How many of us have attended? How many of us know what MNES is? Okay. Please, you guys should do it, please. Like for our own good, you guys should attempt it. So, let's say you want to let's say you guys are using neural network. This guy is 10. From 0 to 9. Say your inputs, you're feeding in what? You're feeding in what? Images. So let's say the image you are feeding in now is 8. Right? And that 8 is, what's the, this is where I want to put that doing is, what's the size of the 8 by 20? So, you flatten it. I don't want, Lawrence has done that for you. So you flatten it, do some other stuff. Let's talk about data augmentation. Let's assume that you don't have sufficient, let us not assume. Let's say you have sufficient data sets, but your model is still overfitting. It's still overfitting in that it doesn't really understand what 8 is. But he's memorizing 8, but he doesn't really understand what 8 is. The solution there is to do what? Data augmentation. So what data augmentation is all about is you can flip it like, if you flip 8, you will get 8.
Yes.
Yes, so you can.
See, you're not feeding it with 3. It looks like it.
Okay, let's say you're not, let's say you are feeding it with something like this. Let's say you're feeding it with 3, and it still sees the 3 as 8. What are we going to say about that?
Underfitting.
It's what?
Underfitting.
It has overfitted. You can kind of say it as underfitted. You can kind of say it as underfitted. But let's assume it as overfitted, meaning that it knows that, oh, if I'm going like this, if I have like this kind of curve, it looks like I have 8. Let's say that, yeah. Then it sees 3. that's that corner too, but at the other side, it doesn't know that this part is not complete. So my point being that in this situation, we are dealing with overfitting. For us to make this model more robust, what we can do is that we can flip our data. We can get, as we are feeding our data while training, we can flip it. We can say this is this 8 now. We can flip it like this. I think this is what flip is. Yeah. You can flip it like this.
You can't see it.
You can. This is 8.
How do we flip it then? How do we?
It's part of Lawrence to talk about that.
Annotation and
Yeah, Lawrence to talk about it. But okay, if you are using, let me just, with respect to PyTorch, you're using PyTorch. While you're loading your data, what we call data loader. So before you load in your data loader, you're going to tell it, okay, as I'm taking in my inputs, flip my inputs. The rotation, we call it compose. We call it compose, I think that's what we call it. So we call it compose. Flip my image. You can share the image, you can add noise to the image, you can do so many things. So you can add noise to this image, you can do anything you want to do. So the logic there is just for it to be more robust to anything. And once it sees 8, you should know that is 8, not 3. You understand? So we can do flip, we can do rotation, we can add noise to it. Then reducing of the complexity of your model, we'll talk about that. So basically, you're just talking about probably you change the hyperparameters of the model. And the hyperparameters here, when it comes to neural nets, what are we talking about? Hyperparameters. Learning? I want you to mention like 4.
Number of video layers.
Okay, 1.
Wait.
There's weight for everyone. So we can't say weight is an hyperparameter. Weight is a model parameter, not hyperparameter. Learning, okay, lambda, yeah, you. Then who should I talk again?
Learning rate.
Have we not talked about it?
The width of the model.
The width of the model.
Width.
Okay, the width of the model, yeah. Then should I stop again? The activation function can be. Yeah, you're right. Yeah, that's true. Yeah, that's true. So now for underfitting, so symptoms, training loss decreases at first, then stop. Both of them are close. Training loss still high. Still high. Remember that 10. Still high. Training loss tracks validation loss. How are you going to solve the problem?
You increase the number of features.
So how are you going to increase? How are you going to solve this problem? I don't want chorus answer.
You increase complexity.
Why?
Because definitely the bias is high. So for us to reduce the bias, we have to increase the complexity. And
thank you very much. So increase the model capacity, just like what you said. Add more layers. Use stable network architecture. So instead of having like something with one layer, maybe you're using neural network. You can use CoVNet this time around. Use convolutional neural network instead of basic neural network. Then decrease the strength of your regression strength. So far so good. You have been hearing so much about regression, and regression is all about what?
increasing the efficiency.
preventing overfitting. So there are other stuff which you can do to prevent overfitting. Early stopping. Early stopping is a form of structural risk minimization. So it limits the space of the model we exploit to only those we expect to have good generalization error. So this is how early stopping is. When you start training, your loss starts coming down. That moment your loss is not improving, it's not coming down anymore. You stop. After, let's say, after like 4 or 5 APOC, you stop. What I said doesn't make any sense. That moment I'm not learning anything. That moment you are saturated as a student. Because once you are saturated as a student, once you understand and any other thing you are learning again, you are just memorizing so that you can write very fast in the exam. So that moment you get to that point, stop learning. Because there you are memorizing. Make sense? So that is what early stopping is. You guys understand early stopping, right? So there are other forms of regularization: weight constraint, L2 normalization. You're going to discuss about that. So then dropouts, I'm going to talk about dropout, then transfer learning. Transfer learning. Let's talk about dropouts. So, how many of us know this? Okay, let me just. This is quite. I'm going to digress a little bit from. I think I have this. I have like 2 or 3 more slides before I round up. So this class is fast. So while I checked for dropout online earlier this morning when I was composing this slide, so I kind of add what can I say? Not serendipity. What do you call this? No, it's not serendipity. I kind of not deja vu. Kind of I started reflecting about the country, especially with I kind of started reflecting about the country because lately I've been using a lot of public transport and the kind of complaint I've been getting. No. So I kind of understand why Nigerians are bitter. Like we are really bitter because, and why I have been using it, kind of made me become bitter somehow. Like I become a very angry person all of a sudden. Like there's something about public transport, especially Monday traffic. Everybody's so Friday night. Don't even go. So it's all a joke on it. It's even worse there. So kind of made me to like reflect on what drop. So I went online, I checked dropout, and from there, probably let me just talk about how this thing is affecting our society. Not just dropout per se, but general dropout. So we said stay in school or drop out of college. So you can see here that this guy is trying to understand algebra, but for some good reason, this big guy is obstructing his view. So this big guy is what? Poverty. And to me, the problem we have with education is not just, oh, this child cannot learn, or this child is dumb. Or sometimes we have not solved basic social matters, social economical matters. We don't have good lights, we don't have electricity, we don't have good roads. So this child has not even eaten and you want him to learn. Why is he supposed to learn?
Even the teacher too is hungry. The teacher too is hungry. And the teacher cannot teach because he's thinking of the children's school fees. So the teacher too has problems.
Everybody,
The teacher cannot in fact bring knowledge.
So teachers has mental problem.
That's one of your side.
What was the mental problem? The teacher is hungry. He's owing his landlord. His children were tripping back from school. That's the poverty there. So you guys
Well, they have mental problem.
no.
Hello. You guys, chill. No. Wait, relax. This is my class.
You earn more than the lecturers.
Excuse me.
The
Excuse me.
lecturers-
Hello.
they just keep
They're not
going
in
because they have no
way.
choice
Excuse me.
and-
Excuse me.
This way, the lecturer say.
Ma'am, there's some teachers in secondary school that learn way less than those university lecturers and impact more to the life of the
They're all
students.
doing businesses. Those teachers are not.
Excuse me,
That's why
ma'am.
you put the
Let's
best
just.
advantage.
I'm sorry. Let's just let's respect ourselves. Okay. So you guys can take your issue outside. So from there, with the social economic matters, we take it down to our family. And from what they taught us in social study, family is the smallest unit of what? Society. So from somebody said like, but let me. It's possible. I don't know, but it's the smallest unit of this society. This family is the smallest unit of the community. So from there, the problem goes to the family. Somehow, school. We'll talk about this. So my point is that, in as much as they keep telling us that, oh, we have to do something about our educational system, but everything boils down to government. Like, we have to address our government. Like, if we don't address our government, we are going to have issues. I'm not just talking about, as we as the young people are going to have issues in the future. So we are kind of doomed. We are stuck here. But even if, the truth of it is that even if you are driving a range today, and that guy is selling gala on the streets, if there's anything, day is going to pick up hands. It's going to affect all of us. So that's just the truth. So no matter how you are trying to make my life better, but it's better you make the life of the people around you better.
Yeah.
If you increase their standard,
Yeah.
it makes your life better. But that moment you think that, oh, let me be that shining guy and oh, let every other person, you are going to lose in the long run. If you don't lose, your children will lose. That's just the truth. So. And if you just send your children out, if you send your children abroad, they will come back at you. They will shall bury them here. So, they will bury them here. I rest my case. So, the next part of it is when university eliminated the ACT education program, I decided to switch over to College of Law. Recent grad out of work, please help. So, this is one problem we are having. Like, when you go to school, you don't know the course you are going to study. It's a big problem. I don't want to be biased with course. Like, I don't want to say, why do you go to school to study history? There is still need for you to study history. It's very important because
What will you do with history? What will you do with history? Or philosophy?
No.
What will you do with it?
So it is
We need it. We need it in humanity.
We need 10
No,
courses.
we need people.
Some countries are facing up some countries. Are you aware? That I have no use to modern day history.
No, not history and philosophy. I'm not going to argue. I'm not going to argue that with you. I'm not going to argue that with you.
Fish, how do you look at it?
Fisheries.
Yeah.
Fisheries agriculture. We need fish.
Hello.
There's hunger in the land.
This
One
is
piece of tomato
hello.
like 50 naira one.
You are not going to solve agriculture problem here.
You can use IT to solve it. Are you aware?
We can do that outside, not here. So, my point is, whatever you are going to study in school, like study something that is relevant, please.
And that has application to solve societal needs.
I know you guys are already here. Probably most of you are through with school. But talk to your younger ones. Let them study something relevant. Study something that has science, technology.
That you like, no matter what you
Please, it's like I will write the name of. I will send both of you outside. But seriously. No. Hello.
I'll also that picture and I'll be better off now.
Excuse me, please.
I'll tell you a lot of things you can do.
Excuse me, please. Hello. You guys.
Agriculture is the best course, one of the best. They are very intelligent. They are more intelligent than science, computer science.
Are you going to take the
I'm more
class?
intelligent.
Are you going to take the class?
You don't know your value. You don't know your worth.
Please let this be the last time you get that. I'm very serious. So,
Sorry.
otherwise, you want to come and continue. So, my point being that you have to ensure that talk to your younger ones. Let them take something very important. Like in the nearest in the next few years, relevant courses with respect to science, engineering, mathematics. STEM courses are relevant. That is what we need now. We are tired of politicians. We are tired of people that don't understand how things work. Because the problem we're having now, we don't really understand. So people don't understand how things work. If you should watch Crash with what's this stuff with Lila and Fowles, what's the name of that program again? The Couch. The kind of people they bring in, most of them don't even understand the way the country works. So it tells you a lot about school. It's not just, it tells you a lot about, it kind of tells you a lot about school. So try to study something very relevant and apply that to what you're doing. So the beautiful thing about AI is that when you study, you can apply it to anything. So that's the beautiful thing. Whether you're in sciences, you can apply it to anything. I have just
Actually, you can study whatever you feel like studying.
Thank you. But my point is, study something relevant.
You can study what you love.
Study what you love. It's very important. But let's be honest.
Studying history.
I'm not saying that I'm not disputing history.
No, that's what I heard. I'm following online. That is what
I
I
know you
heard.
graduate 5 years, 10 years, no job.
No,
MSc,
madam, hello, no. I'm not
So they engineering. I'm selling gala.
Hello, this is my class, please. If you have any arguments, take it outside.
Okay, during lunch break.
Yeah, during lunch break you talk. So my point being that study whatever you want to study, but just make sure that what you are studying is adding impact to the community. Are you okay with that?
That sounds better.
That sounds better. Can we move on? So next slide. This slide is too. So this guy, so this is Kanye West album, College Dropout. So you guys should listen to this. It's not as I'm pushing Kanye West song, but kind of talked about school. Because when he dropped out of school, he called his mom. His mom was like, "You better go back to school." But at the end of the woman needed to like support him. The woman had to like move to Chicago. No, they were based in Chicago. They had to like move to some the uptown of Chicago. So my point that you kind of need your society to help you. You need your family. Then school matters. Whatever you study matters. That's my point. So, and currently now, this thing has not. So, forever.
He's making me because he's smart.
You guys should not make money in this class. You guys will go out.
My voice is
I should do what? You guys should not talk to other people. You guys should not talk to yourself too. So my point is, let's talk about dropouts. So this is dropouts with respect to machine learning now. So let's leave the one people did in school. So if you remember back then. I hope if you are not recording this, it's live. Let's still talk about it. We are no longer in school. So back then now, some of you, if you want to write tests, you have formation. If you want to write exams, you have formation too. So,
432.
See, I'm not going to answer that question. That's your problem. You must have attended the federal school, you know how formation is. So, let's say you arrange yourself like this. So, the lecturer will ball in. Let's say this is the guy that did not jack very well. One is here, and probably one is here. No, you don't want to stay here. This is bad position. Probably there's someone here that you are going to. So they will be supplying you. So then they will be supplying you. So kind of they knock.
George, you are very
randomly they knock this guy out. Oh yeah, you come here. Go and sit down in the next class. When you don't have any, when you don't know anything, you know you are there. So my point is, with respect to neural network, so sometimes this this network, they tend to like memorize. And when they memorize, like this guy knows everything, what the output is going to look like. You understand everything. And why they memorize, but they kind of share. The next slide. So to prevent co-adapting too much. So these guys here, they're co-adapting too much. Yeah. They are all dependent. This one is depending on this one. This one is depending on. Let's say this one is depending on this one. Probably this one will supply this one. I don't know the kind of relationship they have. So they are codependent too much. To kind of avoid that, what you do is that you knock this guy out. When you knock this guy out, if you take this guy and put him somewhere else, let's assume that all of them are well prepared. If you take that guy to the other class, he will still perform well, right? And if you take him out, he's supposed to. They're all supposed to pass. So my point there is, if you want to prevent co-adapting too much, you do drop out. What drop out means that you drop some of your neurons randomly. You can just say drop 50% of my neuron while training. You can say drop 75 from 0 to 1. That's from 0 to 100%. You can drop them. So when you drop them randomly, it kind of makes the neurons to like understand the problem very well, not just memorization. They understand the problem. So when you drop this one, they are supposed to give you the same output as when they are working together. Because what I said, does it make any sense? Does it make any sense?
Which one are we dropping?
Drop your neuron. Look at here, these two stuff that are two different. So these like two different stuff. So you drop this, you drop this guy, you drop this guy, you drop this guy, you drop this guy, you drop them. Randomly, you just.
I don't know. Are they the hidden neurons that is being dropped?
Yeah, hidden neurons. So you don't want to drop your
Output.
drop your output. So during training, the output layer to 0. The output of a layer to 0 randomly with. So you can drop the output. You can drop the output, not like this one. You can drop this one here, not this one. That will finalize, but you can drop anything from here. It's still the hidden. So prevent units from co-adapting too much. Forces network to learn more robust features. So when you drop this guy out, it will force these guys to be more robust. They know that this guy cannot supply them. No show. So you're for yourself. You're on your own. So at test point, dropout is disabled, and units of output is multiplied by P. You don't want to. You can't even drop. You don't want to drop out during testing. It doesn't make any sense to drop out during testing because the essence of dropping out during training is to make your model more robust. So in testing, you just want to know how the model generalizes. So the hyperparameters of your model, of your neural network, learning rate, regularization constants, which is what?
Lambda.
Number of epoch, number of hidden layer, number of nodes in the hidden layer, weight initialization strategy. So can someone explain this weight initialization strategy? What does it mean? What is just what doesn't make any sense?
Basically, you should not allow.
Someone, not everyone. Someone. So,
I guess it means either when you are initializing with using normal with values between minus 0.2 to 0. To positive 0.2, or if it is a model with just one hidden layer, you can initialize with 0.
okay.
I guess.
Partly, you want to add?
I guess for linear and
Simpler, okay.
for simpler problems, you initialize your weight to 0. But when you come to deep learning convolution neural networks, and you don't initialize your weight to 0, you give it random values.
Thank you. From what value?
Let me follow you.
So basically, for what they said, you don't want to initialize your weight with 0. You don't want to do that. You want to initialize your weight with random values. I think it's from 0 to not 0, from something above 0 to something. So you guys should check your slide. It's there. So I can't remember. So that is what initialization. And there's another thing called Xavier initialization. I think I got it. I don't think this is not explained. So check on Lord Xavier. So Xavier initialization. That's another way of initializing your model. Then your loss function is also your hyperparameter. Your activation function. Yeah, you said that. So activation function is hyperparameter. Whether you're going to use a sigmoid function, you're going to use a ReLU. So these are all your hyperparameters. Then we try. Okay, we have discussed about this. That's just it. So yeah, we talked about dropout, right? So whoever you drop out, then hopefully at the end of before you finish this talk, before you finish this session, we should be through with all this stuff here. So thank you. Lawrence.
Your bias might fall in negative way. So when you start from 0, it helps to just move like from minus infinity to plus infinity. So you add down for convolutional neural network, you initialize your and for linear, since you know that the region for it to be linear, it's a straight line. So the region with the bias can fall between minus infinity to plus infinity.
So how
And
can
the
I
app
initialize when I'm setting my dimensional parameters for my code? Like I put my initialization for my code. Why must I? Do you put zero? You just zero for initialization. You seem to be good in this.
I'm not that good, I'm just learning.
Can you, where do you still work?
I'm still a student, really bad.
So you seem to be. I can call you. If you finish the exam, Where are you now? Where is your house? Fine. Can I ask you to come in the morning? How much is the hour? Yes, but I want to do it very well. You understand? So I need to finish it well because there are so many things which I don't do before. What department? It's very good.
Yes.
It's like you guys are not coming to do
Oh, I don't think so before. Yes.
I know you before.
I
We used to come and make party. Yes, actually.
oh, two. Yes.
So you go do it your partner.
Yes.
I need a poetry I can plug in my head. Yes, I
Wow, impressive. The green data science competition.
However, somebody, students, my phone.
Yeah. Sorry.
Lawrence, I think I'm going to.
sit here. But we should move back. We should sit.
I'm charging the phone.
You sit here. This is really the thorough.
This is extra. Last time before.
Okay, hello everyone. Okay, so we'll just be looking at the Titanic data set. So we'll be looking at the Titanic data set and
Are you going to be using the board?
the board. Maybe, I'm not sure.
Okay.
I'm using. So we'll just be looking at the Titanic data set and exploring it and maybe building a model and seeing how the model will perform on the data set. And based on what George has taught about advice on how to apply machine learning. So we'll use that and work with the Titanic data set and build a model, explore the data and see how good of a model we can build to solve the Titanic problem. And this Titanic problem is a popular introductory machine learning problem that anybody who is new into machine learning usually solve, right? Okay, so let me just go to the official.
Can you zoom in on your screen a bit? Zoom in on the screen.
Like this.
Okay. Put it to like 120.
It's not too much. This is 150.
Okay, this is fine. This is fine.
Okay.
I'll just move this guy closer.
Okay, so the competition is currently ongoing. So you can join. Is that? No, it's not finished. I think it has like 2 years more, like so you can join the competition and build your own model also and make a submission. You said?
That's your own problem.
Yeah, that's the first thing you submit actually. It's copy and paste. So you just get a kernel, right, and reproduce what they did in that kernel and submit that. Then you see yourself on the leaderboard. I think I'm also on the leaderboard. Let me see. Let's see. I think I'm number
2000 what? Yes, now.
Our instructor.
No, this competition is crazy.
What's his theory? What's his theory?
Let them do their own and push that.
So I actually didn't do much. I just copied So like it can't even find me. Okay, so I actually use this kernel. I'm bringing it down, sorry. So I used this kernel and I replicated what they did here. So I just copied, I copied this kernel and I ran it and it generated the submission file, and that was what I uploaded. So we'll be going through this kernel as it is. Okay. So like we all know, sorry, I don't know why this thing is hanging. Probably it's trying to get to my position on the. It's hanging, like I can't. So let me just close it, or let me reload the page.
It's always in the ID layer.
Is that? Okay, like we all know that the first thing to do is, well, when you have a problem and you want to solve it, like you first import your libraries, right? So that's basically the first thing you do. So you import pandas, you import numpy, you import random. Okay, you import random, then you import matplotlib and seaborn. Like you use scikit-learn. We are using TensorFlow, right? But this is a scikit-learn anyway. So after importing, you load your the data set. After the importation, like after importing all the libraries that you need, you then go ahead to load your data set. So since we are using pandas, you can just use read CSV. So we read in the train data, and we also read in the test data. I'm waiting for this to load. Like I want to show you the data set. Okay, so after reading in the train data, they will be stored as a pandas data frame. And we all know what a pandas data frame is. We all know what it is. The data frame in pandas. Yeah. I should. Wait, can you all see this? Like, can you see the screen?
Yeah. I'm talking via the live screen.
Okay. So is it okay like this? Is it okay this way?
Yeah,
Okay, so this is the data set, the data. So like in a competition, a Kaggle competition usually have an overview. So there will be an overview that will tell you what the competition is all about. So this is the overview, having a description of what the competition is all about, what the error should be, what error you should use, be it root mean squared error or sigmoid cross entropy loss, and also some information about the data. So you can read this. I hope this is open on your own box. You can open it on your box and probably go through the competition description. Okay, so this is the data here. So this tab has the data, and this is where you get your data from. So this is a description of the data. There is the training set and there is the test set. The training set here is what you will download. You download the training set and then train your model on the training set. After which you will now make prediction on the test set. Having made prediction on the test set, you then upload what you get as your test set prediction to Kaggle, and you'll be ranked and you see yourself on the leaderboard. Then going to the training set. The training set is the training set is train.csv. So the training set is in a file called train.csv. So you will have to download this train.csv to your local box. Then the test set is in the file test.csv, which you can also download to your local box. Then there's a short description of the training set, short description of the test set. Then there's a gender submission. This is just like a guide showing you how your submission file should look like. So let me click on train.csv. Okay. Actually, I'm not going to download the train set or the train set file. Normally, when you use a cargo kernel, your data will be there, so you don't need to download it. You download it only when you are working on your local box, right? When you're not working on a cargo kernel, you download the data set since it won't be available. So the train set now. Okay, so this train.csv, the file containing the train set, and okay, so it has 12 columns. 12 columns means it has 12 columns, maybe 12 pictures, right? But in this case, it will have one column that contains the output, that's the target label, right? So meaning it has 11 features and one target value. So it has passenger ID as one column. It has survived. Actually, this survived is actually your target value. It has P class. It has name, sex, age. Like when you go through the description of the data set, you get more information about all these columns. So passenger ID is an integer, like containing the ID of the passenger. People boarded the ship, right? The Titanic ship, so they had a passenger ID. So it is unique. The passenger ID is unique for every passenger. Then you have the survived column, which is actually your target label. So either 0 or 1. Then P class, the class of cargo. Name is the name of passenger. You have sex, which is the gender. You have age. You have this. So this is just the number of sibling or spouse that is aboard. Then you have you have this. So this is the number of parent or child that is aboard. You have the ticket number. You have the fare, that's how much the passenger paid. Then cabin, the cabin that the passenger was in, then embarked also. You also see the same for the test set. Also, the test set is going to be 11 columns, right? Why is it 11? We saw that the training set was 12 columns. Now the test set is 11 columns. Why do you think it's 11? Yeah. So it doesn't have the output label as part of the columns. Okay, so that's the data. Then there's discussion, there's data board, there's rules, team. Okay, so this is now the kernel here, right? So I copied someone's kernel. So the person has done the exploration, the person has built the data, he has built the model, and he has trained on the data set, and like he has gotten a sample prediction on the test set. You said?
What do you mean by kernel?
Kernel. Okay, kernel is just like you've seen Jupyter notebook, right? Jupyter, it's just like that, but now it is now on Kaggle. Like the same way we have Google Colab, right? So on Colab you can have a code cell where you run your code on. You can have where you write text on Colab. So on a Kaggle kernel, you can do the same thing there also. So you can run code cells also.
So if you are in this function, you can create your own kernel
Yeah, you can create your kernel.
and run your code on Kaggle
Yes.
without using Colab or anything.
Yeah.
Thank you.
Okay, so I'm using this guy's kernel. Okay, so the first thing he did was to import the libraries that he was going to use. And one good thing is, like, if you're using a kernel like this, you don't need to download anything because everything is pre-installed. So Pandas is there, Seaborn is there, Matplotlib is there also, Scikit-learn is there. Okay, so after loading everything, all the libraries that he needs, he then went ahead to load the data set using this line. Yeah.
What's the name of this kernel?
Okay. So just click on kernels. So you see so many kernels, right? So many. So you pick this one. This guy, Manav, Segal. So just pick his kernel. This picture here. So just click on it. Then you can fork a kernel also. Like the way you fork GitHub repos. So you can come here and click on fork notebook. Okay, so you can click here. So I clicked here to get to this point here. So I now have it as, so it is now as if it is my own, right? Okay, so just click here. What is it saying? Name error. PD is not defined. So what do you think happened? Okay, I didn't import pandas, right? So I have to come back here and run this. So I run this. And I can run this. Okay, so I now have my train data frame and my test data frame. So what this guy did was that he combined both data frames. So this train data frame, this test data frame, then he combined them. So he now had a list that contains both the train data frame and the test data frame. So after loading the data, one thing most people usually do is to jump into the model building. So, okay, you've imported your libraries, you've loaded your data set, then you now start building your model. So, probably, okay, so you just start building maybe a logistic regression model. You build the model, then you feed in the data, the raw data into the model and expect it to train and give you a very low error. But that's not the case in a real life scenario, because you are going to get data from someone. Like you're not the one, you're not the one that created the data. So you don't even know what is in the data. Like you don't know what is in it. Like despite the fact that you know what the columns are, you know that it has age as a feature, right? It has pass ID, it has this. Like you really don't know what is contained in the data. Whether there's a missing value, you don't know that, right? So you can't just feed in the data as it is into your model. And one other thing is that your model takes in only numbers, right? So you can't feed in a categorical value into your model. So let's say you have a logistic regression model now, which the hypothesis is theta 0 x0 plus theta 1 x1. Like those x0, x1, x2, x3, they are all numbers. So you can't have x0 as okay, let me look for data. So when I observe this train set now, this train set here. Okay, so I have passenger ID as a feature. I have survived as, okay, this is the target here. I have P class. I have P class as a feature, right? Then I have name. I have name as a feature also. And name is a categorical feature in that okay, name is a categorical feature, right? In that, well, it is not numeric, so it is a categorical feature. So I can't feed this into my logistic regression model, can I?
No.
I can't. So my logistic regression model has x0, that's the bias, right? It has x1 as a feature, it has x2 as a feature. So I can come here now and say, okay, this is my x1, this x2, this x3, but this x3 is not going to be a number, it's going to be this Slopper, Mr. Williams, Thompson, right? So I can't fit this in. So one thing we normally do is to do something called label encoding, in which you encode this as a number. So let's say for a particular feature now, let's say the number of unique values that feature can take is just, let's say, A, B, C, D. So you can just do label encoding. So you make A1, or make A0, make B1, make C2, and make D3. So that's not what you feed into your model. Since your model can't take text, like it can't take string, only take numbers. So after loading your data, like you don't just build your model. So you do something called exploratory data analysis, EDA. So exploratory data analysis means exploring your data. So you have a data set, right? And you want to know what is in that data set, what is contained in it, how are the features related, how many features do I have, can I add more features, can I remove more features, like how do I go about this? So that's basically what you're doing in EDA. So what this guy did was that he analyzed the data. So the first question he asked was, which features are available in the data set? That was the first question he asked. And he answered it. So noting feature names. Okay, noting the feature names for directly manipulating or analyzing this data. These feature names are described on the Kaggle data page here. So, okay, what features are available in the data set? Who knows? Well, if you don't know, you can always check the data page right here. You can go to the completion data page, which is this, right? And you try to observe the features. Okay, I have my training set, right, in train.csv, and I have passenger ID. Can this be a feature? Like you just keep on asking so many questions. Okay, I have survived. Can this be a feature? Can this be a feature? I have 12 columns. Which features are numerical? Which ones are categorical? You keep on asking those questions. So the first thing you do is, like, to answer this question, which features are available, you just check the data page, the page that contains a description of the data set, like on Kaggle. So you check that, and with that you get information, like you get to know about the data better. Okay, then he went ahead and like, since you've loaded in the data, right? So let me just print it out. So what he did basically was to get the name for each column in the data frame. Then he printed it out. So I have passenger ID here, I have survived, I have P class, name, embarked. Okay, so since you've gotten the features in the data set, you've gotten all the features in the data set, meaning that I have passenger ID as a feature, I have survived as a feature, I have P class as a feature. So you then ask another question. So which of these features are categorical? A categorical feature is one that has categories, right? Like something like sex now has just two categories. So sex has male, female only. Gender, male, female. Okay. Okay. Or like yeah, so you try to figure out which of the features are categorical. Then from your observation, so let's come here now and observe, okay, which features are categorical. Sorry, I can't navigate well here. This thing is kind of big. Okay, so we have passenger ID. Is it categorical?
No.
It's not, right. What of survived? Is it categorical?
Yes.
Yes, yes.
Why? Why is it categorical?
Yes,
Well, I'm seeing 001 here.
Survived or not?
Okay, we have P class. Let me see. P class.
Yes.
It's categorical, right?
Yes, yes. Is it first class, second, the coach?
Okay, we have name. Is name categorical? It's not categorical.
It is.
Why?
It's categorical.
Why?
Names. Names. How is it categorical? Can we put them into classes? Mohammed, Lawrence. Can we put into classes?
Okay, is gender categorical?
Yes.
What of age? Continuous, right? Okay. Okay, so what he did was to ask the question, okay, which features are categorical? Then he got the categorical features. So we have survived, we have sex, we have embarked. You said ordinal. Okay, so like we have like there's something called, okay, like in categorical features, like we have one that is just categorical, meaning we have categories, right? And we have ordinal. Ordinal is also categorical in that, like yeah, it is ordered. So you can now like something like P class now. So one class is higher than the other class.
Like first class,
Yeah, so it
class,
has order. So something like sex now, like you can't say male is higher than. You get it? so an ordinal feature is categorical and it is ordered. You get it? Then he asks another question. Okay, which features are numerical? So going back again, so you can pick the numerical features out. So we have age, we have
You also do this manually by going back, coming back, going back. Or can you just do it straight with code?
with code.
Yes, the numerical.
Okay. It's called what? Exploratory data analysis, EDA. So if you can use code, fine. If you can go back and forth, fine. Just explore. You get it? So you are exploring. So numerical features, you get them out. So age, fair, then PR. Then the same way for categorical features that we just have, pure categories, and we had ordinal features also. For continuous, for numerical, we have continuous and we have discrete. So a feature can be numerical and continuous, and a feature can be numerical and discrete also. And we all know what discrete is and what continuous is. Then what else? Okay. Okay. Then you come here and run this. So DF, when you call head on the data frame, what do you get?
First five.
First five, right? So this is just displaying the first 5 examples in this data frame. I have passenger ID, survived, and the rest. And we know the ones that are categorical and the ones that are numerical. Okay, after doing this, you keep on asking questions. So which features are mixed data types? So a mixed data type is probably a feature that has, yeah, it has numbers in it and has letters also. Yeah, alphanumerical. Yeah, something like address. Yeah. So which ones are mixed data types, right? Then you check this. So we have something like ticket, right? Ticket has it has 5. Then you have cabin also, right? You have cabin. Cabin has a number, it has a letter also. Okay. Okay, so you keep on asking questions. So which features may contain errors or typos? Which features may contain errors or typos? Like not even like I'm not even observing the features. Like I'm not going into the values they contain. Like I'm by just observing the name. Like maybe survived. You said name, right? Yeah, name can contain error. Like I'm not looking at the value so that the feature can take, right? So I'm just looking at the feature name. So passenger ID, like can it contain a typo or an error? Can it the passenger ID? It can't now because it is unique, right? So once a passenger comes and registers, it gets an ID. Then survived, well this is actually our target label. So can it? I don't think so. P class is just 1, 2, or 3, so it is categorical. Then name can contain typo, right? So you can spell someone's name incorrectly and you can spell it, in a different way. So just observe the feature names like passenger ID and tell which one can contain an error or a typo. So let me see. Ticket. Yeah, ticket can contain an error, right? Then fare also can contain an error. Yeah. Then cabin. Okay. Okay, so from what he said, it was like, okay, which features may contain errors or typos? This is harder to review for a large data set. However, reviewing a few samples from a smaller data set may just tell us outright which features may require correcting. So name feature may contain errors or typos, as there are several ways used to describe a name, including titles, round brackets, and so on. Okay. So this line will just show me the last five examples. Dot head is first 5 examples, then dot tail is last 5 examples. We are still exploring the data. Okay, which features contain blank, null, or empty values? Okay, usually when you get a data set, they are not usually complete. So let's say the number of examples you have is, let's say 100. You may have some missing values. So meaning that some features may not have values. You get the values may be missing, and you will have to find a way to fill in those missing values. So the next question to ask is, which features contain empty values? Which ones are not complete? That's also another question. Then you still have to explore your data. So it was like, okay, let me just come here. Let me observe. Like if you see something like NaN, so that's an empty value, meaning that no value was provided for that particular field. Let me see if there is anything like NaN or none or anything like empty. Because there's no empty value. Okay, I'm seeing something here. So there's nothing here, right? So meaning that cabin, yeah, has some missing values. Nothing was provided here. Nothing was provided here. Let me see. Okay, let me go back to the code. Okay, so when you call, okay, let me know. Okay, so this is info. So when you call .info on your data frame, it lists the columns you have for that data frame and the number of unique values you have and number of non-values you have, and also the data type for each column in your data frame. So by calling unique on this, I can see that I have a number of 891 examples. I have 891 plain examples. Then the first column, which is passenger ID, has 891 values, right? There is no null value there, so passenger ID has no missing value, and it is an integer. Then survived also has 891 values. Okay, then when you come here, age has 714 non-null float 64 values. So what does this mean? It's not complete, right? So I have 891 values, 891 examples. Then the age feature has 714 values, meaning that it is missing about I think 100 and something values, right? And it is float 32, is a float. So you can have age is float. Let me see. Is that? Okay, so you can have age of 12 point something, right?
12.5.
Yeah, 12.5. Okay.
That's how they define their own.
Yeah.
But some make it discrete value.
Okay.
Depends.
So you can see cabin just has 204 field values. Then, okay, this one is complete, this one is complete, this one is complete. This one has missing values. This one is complete, missing values. Then embark also has some missing values also. I think just two. This for the train set. Then for the test set, I have 418 examples in my test set. And they all, let me see. Wow, even the test set has missing values too. So age has missing values. Cabin also has missing values. So imagine you without doing exploratory data analysis, you just took the data this way and built a logistic regression model and then fed in the data. Like, your model won't learn anything. It won't learn anything at all. Okay. So, what other question did he ask? What is the distribution of numerical feature values across the samples? Okay. Yeah.
I thought you said you have smart both
Yeah.
So how is
what he did was that he created a list, right? A list that has just two elements: train data frame and test data frame.
Okay, the margin is like
Okay, let me show you the code. So what he did was that he just did train.info and test.info.
okay, is running on each separately,
Yes.
not on the margin.
No. So train.info, then test.info, then he printed underscore times 40, that's 4 times 40. So you have 40 underscores. And this is the result here. So this is train info here. Then after train info, he printed underscore times 40. Then test info here. So what is the distribution of numerical feature values across the samples? Another question. Well, this helps us determine, among other early insights, how representative the training data set of the actual problem domain is. So like, you have numerical features, right? So you want to know. So you want to know the distribution. So like how many numerical values do I have in this numerical feature? Something like you having, let's say, okay, you have a numerical feature, right? So like you can get the mean of the values in that numerical feature. You can get the standard deviation, you can get the maximum value, you can get the minimum value. You can't do this with categorical features, because for a categorical feature you can't get the mean, because it's just in category. Something like size now, maybe large, medium. So the mean of large, medium, and small is, I don't know. There's no mean. You can't add them. You can't divide. You can only get mode, right? So coming here now, you just do okay. Main df.describe. So what describe does is to describe the data set. So it will tell you the distribution, like what the mean is, what the standard deviation is, what the maximum value is, what the minimum value is, number of unique values and all that. So for passenger ID now, I have 891 examples. The mean is 446. The standard deviation is this. The minimum value is 1, and the maximum value is 891 because they are unique. So I have passenger ID ranging from 1 to 891. So the first passenger ID is going to be 1, second 2, like that. So this is like a unique identifier. So if I want to get a passenger, I can get that passenger by the passenger's ID. His ID will point me to him. Then survived also 891 examples. The mean is this, P class, age, and all that. Then you can also do the same for the categorical feature. So what is the distribution of categorical features? So we've seen numerical features, right? We've seen the mean, the minimum value we have for a particular feature, the maximum value we have for a particular feature. So you do that also for the categorical features. So let me just call describe on the categorical feature. Okay, so it will do the same thing. Only that in this case we can't have mean, we can't have standard deviation, we can't have minimum and maximum. So we can only have unique, can have count, and can have top. So what do you think top is? The first value. Okay, top is actually the mode. Yes, the top, meaning that the value that appears most, right? So here I have 891, then unique 891 also, then top is this, frequency is 1, like the name should be unique anyway, so it appears once and it is the mode. Like strange. You said?
I have a different top. Does that mean
a different
top?
Top.
Yeah.
For name.
Yes, for name.
Or for sex.
Male. Sex, male.
Same thing. This one is like.
And for
actually, I don't think that there's a top
It's different
because
for
the name is name is actually unique, right? So there shouldn't be any mode.
I think it's likely to be the first item.
First item. So you just pick the first item because there is no mode, right? Like they all occur once, like each occur once. So you just pick. Okay. Then cells has just two values, male or female, and the mode is male, and it occurred 577 times out of 891 times. Then ticket also there's 891. Then we have 681 unique values. Then this is the mode. This is the mode for cabin. Then this is the mode for embark also. So we've explored the numerical features, and we've also explored the categorical features. So we keep on going. So assumptions based on data analysis. Okay, so there's something you do also. So like when you get a data set, so the data set usually comes with so many features, right? And it will also have a target value. So this is the label, and you have to build a model that will give you a prediction. So one thing you do is to check how well those features are related to your target value. So you check the correlation between your features and your target value, and you remove those features that are not related to the target value and keep the features that are related to the target values. So that was what this guy did. So it was like we arrive at the following assumption based on data analysis done so far. Okay, we may validate these assumptions further before taking appropriate action. So it was like correlating. We want to know how well does each feature correlate with survival. Remember that survival is the target value that we want to predict. Survival is either 0 or 1, and that's what we want to predict. We want to do this early in our project and match these quick correlations with model correlations later in the project. So we want to see how well these features are related to the target value, which is survival. Okay, we want to complete age features as it is definitely correlated to survival. So what does this statement mean? Is that? Okay. And remember that the age feature has missing values. Okay. So normally what beginners usually do is, like, if they find a feature that has missing values, they just remove it. Like, this is not this is not an important feature, so they'll take it out and keep those ones that don't have missing values. But here you're saying that we want to complete age feature, though age has missing values, but age is highly correlated with the target value.
How do
right?
you know? How do you know that?
From logic now.
Yeah, from logic.
But there are
What?
but there are a lot of problems that
Somebody
you
who
can't
has
use logic for.
hypertension, who has
Yeah.
lung disease, and you, a young boy, nothing. Survival.
So how you know first is from logic and from domain knowledge. Yeah, there's something called domain knowledge. So someone who has domain knowledge, like,
Okay, doctor.
yeah, so you can get your knowledge by actually reading the competition description. So they're like, the sinking of the Titanic is one of the most infamous shipwrecks. Like, you can even go on Wikipedia and read up, about the Titanic incident, right? And get domain knowledge, like, study it, and you know a lot about the incident, when it happened. You can even watch the movie also. You watch the movie and understand it very well. So they're like,
Can you bring out any phrase that is pointing to?
there's even a video. Like, you can even watch. You watch. So as you are doing this, you are gathering domain knowledge, like you are understanding what happened, you are understanding so many things. Then I think even for me, they're like one of the reasons that the shipwreck led to such loss of life was that there were not enough lifeboats for the passengers and crew, although there were some element of luck, right? Okay, so there was some element of luck involved in surviving the sinking. Some groups of people were more likely to survive than others, such as women, children, and the upper class. So by this now, you know that the features that are highly correlated, with the output target, sex, age, gender, age, and class. You said? And class. You said? Upper class. Class. P class. P class. So you just know, like, even without you exploring the data, like by just knowing what happened on that day. So you can tell.
Is there any code for
knowing?
Code? Yes.
Okay, let me help you now. It's not every problem you have information or video as data scientist or machine learning expert. We try to give you the problem. If you don't know what the Y, the X's will be, look for the domain knowledge expert, because you're not supposed to work in your own data science. You're supposed to go to the domain knowledge people. Let's say no video and all that. They will now tell them this is the problem. What leads to this? What affects this? All that.
What if there's no time and you're in the competition and
you think, you read up in a competition. See, you will know. You will know.
Thank you very much.
What I'm telling you is my friend who
Okay, so you find the features that correlate well. So we have age, there's embark also.
What does this embark mean?
So you come here also, check data.
Okay, description.
Yeah, data description.
One can read it up, don't worry. Let me not waste your time.
Okay, but I'm there, right?
If I want all this information, let's say I log into my Kaggle account, how do I see all this? Is it to type Titanic and search? Or you give us this link? Okay.
No, you can, it's a very popular competition. Just type Titanic to come up. Okay, let's continue. So we know the features that are well related with the target value. So we will keep those features. So then we now go to correcting. Remember, some features had missing values, right? And you can decide to fill in those missing values, or you can drop that feature entirely. Like that feature, just take it out. From our observation, we saw that a feature like cabin. Okay, cabin has just 204 values, and we have 891 examples, right? So out of those 891 examples, it has just 204 values filled, meaning that it is missing about 600 and something values. So you can decide to start filling those values, so you can just take out its cabin, right? Filling cabin. I think we should remove it. Actually, it has a lot of missing values, and filling like we are not getting a proper distribution. Like you don't have all the values. Like even if you find the mean or the median, like you are not getting the right. So it's better to just take it out. Or if you suspect that cabin correlates more with the target value, you can try to keep it and fill it in. So you can probably fill it in with the mean or the median. So you can just pick those missing values. You can start filling them in with the mean or the median. But since it has a lot of missing values, the best thing is to just take it out.
Oh, sorry, a random question.
Yeah.
I know this stuff in real life when it happened, like the ship broke into like 2 parts. What would you say if
The ship?
I think the ship broke into like 2 parts when it happened, like in real life, the ship broke into 2 parts. What would you say if maybe the cabins on one side had a higher chance of surviving than cabins on the other side? If he needs to get the cabin, is there a way?
On the story,
From the story, it sounds like he might play a role.
Yeah, it might. So you
they're
get
not
that.
surviving anybody.
So it probably
There's been some rescue operations that are actually taking place. People, they try to rescue a lot of people before it got broken eventually.
Exactly.
Before it got broken eventually, there's been some rescue operation. They brought in a lot of, what's it called, these speedboats to rescue a lot of people, and those are the people that have higher chances of survival. You understand? So it's not just when it's got broken or the cabin, that might play a part, but it's going to play, it's just going to be one of the features that should be considered. Meanwhile, other ones like those people that were rescued first, they are either you're a female or you are young and you are what do you call it, a child, and that. Then if you are one of the crew members, you cannot leave the area. So those ones are, and even if they are on this side of the cabin, they still get, they still die
Okay. So the guy has correlating, completing. So you complete the features that have missing values. Then you go to correcting. So meaning that you can take out some features, right? So ticket feature may be dropped from our analysis as it contains high ratio of duplicates. Really, 22%, and there may not be a correlation between ticket and survival. So he identified this feature, ticket, that there is no correlation between ticket and survival, so he dropped it, and it has duplicates again. So this is, yeah. Then cabin also.
Don't be annoyed.
Yeah.
Like, how did you get to know that it has duplicate of 22%?
So okay,
I'm very sure
like
you
how
don't check
do you know that it has duplicate of 22%?
I'm very sure you did not check it from 1 to 99.
So you can come here. Where is it? Ticket, right? And you have 681 unique. Like ticket is meant to be 891 unique because ticket has to be unique, right? Yeah, because so one ticket for one person. So if I have 891 people, then I should have 891 tickets. So having 681 means that I have non-unique values. So you can calculate it. Let's say it's 20%, right? So if you 29.18.
Yes,
okay, 21.98. Yeah. So this is like 22% non-unique values.
So we have to make sense from this summary. Okay, continue.
Would it be possible that missing tickets represent the crew members?
The crew members. Yeah, that's another thinking. Yeah. So with that thinking, you can decide not to drop ticket.
They give ticket to crew members.
Yeah, that's also another thing.
They don't give ticket to crew members.
Because
That's what he's saying.
We didn't give
That's why
ticket.
they are only 681 units.
Yeah.
So the others should be not the number. Listen, yeah.
No. I mean, wait, calm down.
No, they sell tickets to passengers.
681.
They don't sell
And
to
there
their
are
men, to
89.
their staff.
No, this is unique.
Unique means
This is unique. Meaning that we have 681 units. And some were repeated. Yeah, meaning that we have, you get, let's say I have 5 examples, right? And I have 2 unique examples. Meaning that I have repeated values from those 2.
Maybe they were underage children.
Describe,
Could be the
Yeah.
underage.
describe wants to show you that the values there, the other 22% actually missing values, not the values. How would you show?
Okay, that they're actually missing values.
Not no value there.
Wait, come again. No, come again.
Maybe there are 681 tickets.
Yeah.
Others are just missing maybe any.
NAM.
Yeah.
They may not be missing count. They could be,
Look at count is 891. So there's no.
Yes. They may be underage because underage children don't pay for tickets. They don't pay for tickets.
Lawrence,
There's a
the
certain
count
age
for
you-
cabin is
you
2.
don't
That
pay for
means
tickets.
out of 891.
891.
Yes, they will pay for tickets. They may be attached to the parents. Like a small child now, you pay for tickets. It's free. So there are systems that are so.
Yeah.
Yeah, grandchild,
Yes.
like spouse.
They don't pay tickets.
Just pay.
They give them yes,
This
yes.
is what we feel correct.
It's possible they
It's
give
like a
them
framework to go to every time of problems, just get
Yes.
Like you can go through any framework you want. It's called EDA.
just explore.
Yeah, just explore the data.
That's
Like you can't just feed in. Like you can't just.
As it works.
You can't just get data now and feed it into your model. It won't work.
So are there predefined ways to
You said?
Are there predefined ways that you can like step by step explore?
Yeah, this is step by step explore now.
This is standard or just this guy?
No, this not like there's no standard.
It depends on the problem.
Yeah, it depends
The
on
nature of the problem.
Right.
You do some thinking to know what to do.
Like the first thing to do is to get domain knowledge first. Like you need to understand what you're actually solving. Like you can't just start solving.
So what I mean is, you know, you have steps like correlating, computing, correcting. They sound like very
Okay. Yeah, like that's how he wants to do it. Correlate, complete.
This is
correct.
not approach.
Like this is approach.
There's no standard approach.
You can decide
Devise
to
yours.
like if I'm to do this, like the first thing I'll do is just to get the categorical features, get the numerical features, do label encoding for the for the categorical or one hot encoding, then fill in the missing values. And that's it. Fill it into my module. And I'm done. You get it? But you need this. So it probably like doing that, my model won't learn well because ticket ID, is it ticket? Yeah, ticket will be there. Like it will be part of the features I'll feed in. So I'll now start, probably after doing that, let's say my model didn't perform well, and I'll now start playing with the features again. Yes, going back and forth. But this is like a very good approach, right? You perform your exploration first, then after the exploration, you build your model, which is great. Okay. So it created new features also. So we want to create a new feature called family based on this. So he discovered that this feature yeah, this is like parents and children, right? So this feature tells you the number of parents and children, parent child, right? Then this like, okay. Oh, sorry. So this like for a passenger now, right? The number of parents / children that particular passenger has.
That's the same ID for the children.
Yeah.
That's it. Children don't pay abroad. They have social security, I mean, they don't pay.
Yeah.
Things are free.
Yeah, so a child doesn't have a passenger ID.
That's the difference.
Wow. Okay.
They don't pay abroad.
Yeah. Then there's siblings slash spouse, right? So this is telling you the number of siblings or spouse that a particular passenger has, right? So it was like, you said? I don't know. I don't know about that one. So it was like parent, child, sibling, spouse. You can call that family. So he created another feature called family that is just an addition of this and this. And that's by exploring the data. Like you couldn't have gotten this without exploring the data. So it was like we may want to engineer the name feature to extract title, right? So we saw the name feature. Where is the train.csv? Can't find it again. Oh.
Just click on train.
Can't find it again. Okay. Okay, after observing the name feature, right? So this is what he has as name. So you can have something like McCarthy, Mr. Timothy J. You can have Moran, Mr. This. So this is the person's name, Allen, Mr. William Henry. So it was like you can extract useful information from this feature. So he extracted the title from the feature. So coming here now, you can extract the title. So you can extract Mr. Meaning that you can have another feature called title, right? That will have the title for each passenger. So this passenger has the title Mr. This passenger has Mr. This one has Master. This one has Mrs. Then okay, we may want to create new feature for age bands. This turns a continuous numerical feature into an ordinal category. Yeah. So you can actually convert a numerical feature into a categorical feature. So something like age now, age is numerical, right? So you can convert it to categorical by having bands, right? Age bands. So you can have, let's say, 0 to 20, no, 0 to 10, maybe 10 to 30, 30 to 40, no, 30 to 60, then 60 and above. Right? Yeah. So in that case, it has become the categorical feature, which is ordinal. So you have child, teen, like that. Then we may also want to create this. So fare is actually like how much the passenger paid something. So he created something like fare range also. So that's also converting a numerical feature into categorical. We may also add to our assumption based on the problem description noted earlier. So women were more likely to have survived. Children were more likely to have survived. The upper class passengers were more likely to have survived. Why?
They said it.
They said more.
They said it on the.
Yeah, I know, but why upper class?
They paid more now. Those are the rich guys.
First you
Now one of the richest guys you know.
Okay. So we've analyzed the features and we saw how they correlated with the target value. So another thing to do is to see how a feature correlates with other features also. You can also do that. but we'll get to that later. So it was like, okay, analyzed by pivoting features. Okay, so still the same thing, seeing how well the features correlate with the target value. It's still the same thing here. Only that is now writing code for it. Okay, so this is P class. Remember that our survived has just 0 and 1, right? So it has just 2 classes, 0 and 1. 0 means means that the passenger died, something. Then 1 means that the passenger survived. So what this line of code does, so we know what dftrain is. Dftrain is the data frame that contains the train data. Then it just took out P class and survived from this data frame. Then it grouped it by P class. Grouped by P class, right? Then it found the mean.
What does that actually mean?
As index. Meaning that since you are grouping by P class, if you put this as true, then P class will become the index, meaning that this index will actually be P class. Okay, then he found the mean, then sort values by survived ascending. So meaning ascending, wait, this is like descending. Okay, descending, yeah, false. Okay. So meaning that when he gathered the number of passengers from P class 1, right? Let's say you have 10 passengers. Let's assume you have 10 passengers from P class 1. So meaning the survived value for each of them will either be 0 or 1. So let's say you have 5 zeros and 5 1. What's the mean? 0.5. So meaning you have equal values. So it is equally likely, right, for P1. Sorry. A passenger in P1 class has 0.5 chance of survival. That's what it means. Let's now assume you have like 7 1 and 3 0. So what's the mean? 0.7, right? So that's basically what was done here. So pick from P class, then find the mean of survived. So you got something like 0.62. So meaning that passengers from this class were more likely to have survived than passengers from this class. So this one is like 0.2, meaning that
The moral of the story is that we should be rich.
Yeah.
It's like
Rich. Means that you should have money, right? Okay.
Everybody here has the potential to be a millionaire.
So guys from class 3, majority of them died. Right? Meaning that the probability of survival here is 0.2. Right? Meaning that most of them died. They all died. Most.
80%.
Yeah, 80% died.
I mean, if we are a woman,
Survive now. I thought it was just that 0 1.
Yes.
How did they arrive at that?
Yeah, I explained. So what this does is to sample P class and survive, right? From the training set. So let's say for P class 1, let's just give an assumption now. Assuming for P class 1 we have 10 passengers from P class 1, and you know survived only take values ranging from 0, no, like it takes either 0 or 1. So out of those 10, I have like 5 1 and I have 5 0. So what's the average? What's the mean? 0.5. So if I have 7 1 and I have 3 0, the mean is 0.7. So that's how we arrived. So we typically took all the passengers from P class 1 and average their survive to get this. That's what this does. So you take P class and survive, group by P class.
So that means we are looking at the probability of
Yes, yes, yeah. So P class survive, then we group by P class, then you find the mean, then you sort by survive, then ascending equals false, meaning that you start from the highest, then you keep on go down, that's descending. So let's try for this. Let's try for sex. Same thing. You have this. So female 0. Female is 0.74. The male is 0.1. Okay, let's say. Okay, so this is siblings, spouse, right? Siblings and spouse. So let's find their own distribution. So we have, so 1 means that you have 1 sibling like spouse. So siblings or spouse, right? So this passenger has just 1. This one has 2. This one has 0. So from here now, it means that, like, this is saying that, no, this is saying that the more siblings my spouse you have, like,
so one man to themselves, you want to survive.
And if you don't have any sibling or spouse, like,
It's
low,
it's too low.
like,
So at least get 1 person.
yeah, at least get 1. Like this guy gets yeah. But if you have more, like, yeah. Okay. So this is parents, children. Okay. So this is like the same thing. The more you have 0. Then if you are in between, you are good. So someone with 3 that's in between is okay. Someone who has few is okay. 0 is 0.3. Okay, that's the same thing. So like after creating all these, like call them these lines. Okay, sorry. After creating all this, we then went ahead to visualize. So like you've actually visualized, right? But in this case, we used a table to visualize them. So he now went into visualizing by using plots. Instead of using just tables to see, the correlation, so he's now using plots to see how well they are correlated. So you can read this. Okay, so from his observations, infants had high survival rates. Oldest passengers survived. Large number of these did not survive. Okay, that was young guys. Then most passengers are in this range. Okay. So basically, like what we did here was just for the categorical features. Yes. What we did here was just for the category. Oh yeah. Don't see it as pulling. So what we had here was basically for the categorical features. So for numerical features, I think we just have to visualize using plots. Just have to visualize using plots. So let's now visualize using plots. So there's something called seed 1. Seaborn is used for visualization. It is built on top of Matplotlib for visualization, and it is easier to use Seaborn. Is it easier? Like
It just has more.
yeah.
Function.
Seaborn has more functions to use, for your visualization than Matplotlib. Like if you were to use Matplotlib, you have to implement everything. Yeah, but Seaborn has already implemented them, right? So it is using Matplotlib as a back end. So with Seaborn, like normally to do this with Matplotlib, you have to write a function that will do this. You have to convert this df. You have to convert it into a NumPy array. I think you have to do so many things to achieve that. But Seaborn makes it easier. Okay, so what we are plotting here now is we are plotting age, like histogram of age. So to know the number of passengers that survived and died, right? So this is age, right? And this is the number. So for 0, so 0 means that the passenger died. So we have this distribution. So passengers that were below 0, like had 0. And passengers that were above 80 had 0. Like then here also, okay, then passengers between 10 and 40, or let's say 30, like had the highest number of deaths. Then when you come here, the same thing too, passengers here. But remember that majority of people on the ship were, like most passengers were between 15 and 35. So you saying this shouldn't excite you that guys between 15 and 35 survived more than. But coming here, like this should be the main thing. Like most of them died. Okay, so you keep on doing the exploit from the data. So let me just run all the plots. Okay, so this is now P class and survived. I think this is a histogram of So it's now combining survived and P class. So it's combining age, survived and P class. So this age here, then this P class 1 and survived 0. This P class 1 and survived 1. And this age. So you can see how it is. So for P class 3, you can see that majority of guys in this range all died. Then let's see P class 1.
Imagine.
Okay, P class 1, like just.
You are still the hero.
And majority of them survived for P class 1.
That's what I'm saying. You don't have money. You're playing hero. I don't mean that as a bad thing.
So let me see. Okay, P class 2. Okay, the same thing for P class 2. Like this P class 1. Okay, yeah. Majority survived. So the same thing for P class 2. They are just there, like just just in between. Okay. Let me see this.
Ideal society.
Okay, so let me just run through all the plots. I don't think we should focus on Okay, so he now went ahead to wrangle the data. So we know what wrangling data mean, right? So wrangling data, like you add, you remove, like just wrangle it. So we have collected several assumptions and decisions regarding our data set and solution requirement. So far, we did not have to change a single feature or value to arrive at this. Let us now execute our decisions and assumptions for correcting, creating, and completing those. So wrangling data means to change them from here. So you change, like you drop features, you correct missing values, so you replace missing values. Okay, so I think we said that we're going to drop this ticket ID. Okay, so it dropped ticket ID. Is it ticket ID or just ticket? Ticket. It dropped tickets and it also dropped cabin. So based on our assumptions and decisions, we want to drop cabin and tickets. And we know why we are dropping cabin. Why? Why are we dropping cabin? The missing value is too much. The missing values. And why are we dropping tickets also? Duplicates. Yeah. Okay. So, invalid syntax. Delete something. Rain. Oh, wait, so you can actually run something like this.
Yeah.
Wow,
Yeah.
this is nice. Okay, so I removed, I dropped cabin and tickets. So this is what does that. So train.df.drop ticket cabin. So you drop it for both the train dataset and the test dataset. Then you update the combined list, right, containing train df and test df. You said? As this one. As this one is like this. As the zero is like this. Wait, as this one. Yeah, as this one. Yeah. So train df.drop, so ticket cabin, then axis equals 1. Yeah. 1. 0. Okay. Test df.drop this axis equals 1. So after before dropping cabin and ticket, we had 891 examples, then we had 12 columns, right? So after dropping them, we still have 891 examples, and then we now have 10 because we dropped 2. Then for the test set, we have 418, then we have 11. And the reason why we have 12 here is because we also have the target value as a column, right? So it's going to be 12. Then the test set does not have the target value with it, so it's going to be 11. So this becomes 9. Okay. The list. Okay. Then creating new features from existing. So remember, we said that we're going to create new features. So we're like from family, from siblings, spouse, and from parents, children. We're going to form another feature called family, and we're also going to extract useful information from names. Right? So we can extract title. So mean that we're going to have a feature called title and a feature called family. So you do that. So this is what. Remember we have in the combined list we have train data frame and test data frame. So if we are going to form a new feature, right? So that feature should be present in both the train set and the test set. So we are going to look through this, which has the train set and the test set. Then we are going to add title. And what title is just extracting the title from name, right? So data set dot name will give us the name column. Or you can also do data set square bracket then name inside. So who understands this? Yeah, regular expression. Who understands this regular expression? First, start to laugh.
Find anything that is
Big letters, small letters.
Big letters, small letters.
any character,
Yeah.
like A to Z or anything that has A to Z,
Yeah.
capital or small letter. Find it. One plus means that it has to, at least you have to find one. Do you understand? Like one or many.
One or many, yeah. One or many. Star is
Zero or
or
many. Is basically
okay.
match everything.
Then there is a full stop
It means
beside
that
it. Yeah.
the reason why you use backslash is because full stop itself means something in index. So if you don't use that, it will match everything. But backslash full stop means I want the literal full stop itself.
So you are like escaping.
Yeah,
Okay, so what this will do is to just come here. So it will go to name and look for a match. Like it will look for anything that matches this regular expression. So this regular expression is just okay, capital letter A to Z, right?
Any character, one or more that has full stop after it.
Yeah. So I have capital letter A to Z, right? Then small letter A to Z. Then plus means that any number. So it can be 1, 2, 3, 4, 5, 6, 7, 8. Then it must have dot at the end.
Yeah.
So it will come here and it will look for a match. There's a match here. So it will pick this. So after picking that, it will like this will do this for each element. So it means that you are going to have a series, right? Then you assign it to the title, and you do this for both the train and the test set. Then you do pd.crosstab. What does this do? Who knows what crosstab does?
This is the first time I'm saying it.
I don't know what crosstab is. Oh, this is crosstab. Okay. So like after doing this, then you do crosstab. So crosstab will just do crosstab, right? So crosstab, you have one like this, you have one like this. So that's like a cross. So this is for the first one, and this one is for the other one. So we have sex here. Sex is this. Then title is for down. Right? So that's crosstab.
Okay.
You understand? Like yeah.
You have sex.
Yeah. So this
So what is the pivot table?
pivot table. Yeah. There's also pivot table.
Yeah.
But one thing about pivot table is that you have to specify the value. Right? You have to specify the value. But crosstab we will just map them, right? Yeah, we just map them. For pivot table, you need to specify the value at that position. Yeah, the value you want it to be. Wait, sorry, cross tab is even counting them.
Yeah, that's what I'm saying, it's counting.
Yeah, so yeah, it does it. So cross tab is going to give you the count, right? So it's counting them. So meaning that for this title now, that's captain, right? Yeah, like you can't have a female captain, obviously.
No, maybe then 1912.
Yeah, then male, just one. So a captain, like, well, yeah. So you have just one captain on the ship, right?
Yeah.
Just one captain.
One captain, two colonel.
Then countess, like a guy cannot be a countess, obviously. Like then miss, so many miss, zero.
I don't do that more.
So what pivot table is like? If you use pivot table, you have to specify the value you want. So let me see. So there's no need. So pivot table, probably you can specify the value to be maybe survived, and to start putting it.
Yeah, that would have been interesting. But how do you do it? Can you have three?
Survive. Can you have? Yeah, you can have. No, you have one like this. Then okay, let me try pivot table.
Okay, to count based on survive.
Oh, to count based on survive. Wow, you have to. I'm not. Like this is just counting based on the number. Yeah. Okay, so even after extracting the title from the name, it was like there are so many titles and some don't even make sense.
What is junk prayer?
Yeah, like what was this junk? What was Dawn? Imagine Dawn.
If it's a Nigerian chip.
Yeah, you see Alaji. Alaji. You see Bishop.
It's MME too.
The Reverend, yeah.
You see one Alaji Reverend.
So it was like we can replace many titles with a more common name or classify them as rare, right? So some titles like Junkie now will be rare. Titles like MME, these ones will be rare. Master will be Master. Okay, so that was what he did here. He did that for the train set and also for the test set.
And he used intuition for stuff like Miss MME to Mrs.
Okay. Okay,
MML should might be Mademoiselle.
Mademoiselle. Okay. Mademoiselle. Okay, this one's okay, yeah, female titles. Okay, change this ones to Miss, then MME, Mrs.
Maybe since he checked that it was under female. When he counted it.
Okay, this one, okay, MME is under female, mile is, sorry, male. Male is under female, okay, this is under female, so, okay, this should be Miss, then this is Mrs., and there's no Mrs. here, seriously. There's no Mrs. I'm not seeing Mrs. Yeah.
0.
Oh, wow. No wonder so many females survive. Right?
They're mistress. Is that what
I'm sure.
I have Mrs. You have different data sets. I have Mrs.
You have Mrs. Oh, I've seen Mrs. Are you serious? What was I seeing before? Okay, so let me run this. Okay, so you now have like five unique titles now. And okay, this one survived Miss, Mr. like those few. Then Master are like the small guys, the small children. Then Mrs. 0.7. Wow.
Who did this?
Okay. Then we can convert the categorical titles to ordinal. Okay. So converting the categorical titles to ordinal means making them ordered, right? So you have a categorical feature, then you want it to be ordered. So you start from Mr., Miss, Mrs., Mas. Like I don't know why he did this. Like actually I wouldn't have done this. I don't know why he did this anyway. So this like is actually doing label and coding here. So there's something called label encoding, right? When you have a categorical feature and you want it to be in numbers, so you can just convert it to ordinal using label encoding. So he is saying that Mr. should be 1, Miss should be 2, this one should be 3.
Is it not going to lose information?
Yeah. It will definitely lose information, but this is his approach. Okay, let's run this. So he has done that. Okay, so he has converted. Wait, was it all? Okay, so he has converted title to ordinal. So he has done label encoding for title. Then you go on. So we can now safely drop the name. So since you've already extracted the useful thing that you need from name, so you can drop it. You don't need it again. So remember, I've dropped name. Why am I having 99?
Drop name.
Oh, sorry.
Drop name and added type.
Okay, so you drop name, like you actually dropped name and passenger ID. Because basically like you don't need passenger ID to train a model with. So you dropped name, then you dropped name.
We left passenger ID in the test.
In the test.
Why?
Okay. Like you will change that later.
We'll change that.
Okay. Converting a category. Now we can convert features which contain strings to numerical features. This is acquired by. Okay. So it's basically doing label encoding. So if you remember that you can't pass a categorical feature value as it is to your model. You need numbers. You need to feed in numbers to your model. So you have to do label encoding, meaning that you are converting those feature values that are not in numbers. You are just changing them to numbers. So something like female now. You can't pass female to your model. It won't work. So you have to change it to like a number. So make 1. So female 1, male 0. And this is called label encoding. There's a variant called one-hot encoding, which you can also use.
Instead of this point.
And instead of label encoding, you can use one-hot encoding. One-hot encoding. So one-hot encoding means, okay, to do one-hot encoding, you typically add more features. So you have a feature called sex, right? That takes 2 values. So it takes either male or female. If you are doing label and coding, you just replace female with a label, let's say 1. Then you replace male with 0. That's label and coding. But for one-hot encoding, you have to create a new feature, right? So that feature will become 2. So you have sex male, then you have sex female, which will be one-hot encoded. So if it is male, then sex male will be 1, sex female will be 0. If it is female, sex male will be 0, sex female will be 1. Do you get? So that was one-hot encoding. So imagine if your categorical feature takes, let's say, 100 unique values. So doing one-hot encoding means that you're going to have like 100 additional features. Right? So let's say it takes A, B, C, D to, let's say 26, right? But let's just say, okay, let's use 4, right? A, B, C, D. So it takes A, B, C, D. So if you are doing one hot encoding, it means that that feature will now have the A version, B version, C, D. So meaning in your features, you are going to have the A version of that. So let's assume the name of the feature is F. So you have FA, you have FB, FC, and FD. In that, if that feature value is actually D, it's going to be 0, 0, 1, 0. So that's one hot encoding. So doing one hot encoding increases the number of features you have. But it did label encoding.
So what's the advantage?
Okay, the advantage of one hot encoding is that like when you do one hot encoding, you are not giving preference to any class in that feature. Like now, doing label encoding means that female now has more weight than male, right? So female has 1 and male has 0, and this can affect parametric models like logistic regression. In that, in a model like logistic regression, you have to compute something called weighted sum. So you typically multiply this guy by something, and this will give you a high value, right? If you multiply this, and this will give you 0. Yes. So it is actually giving more weight to a particular class than another one. So that was one disadvantage of label encoding. And most times, label encoding works fine in that when you know the distribution of your data set, right, there's something called mean encoding. It is a variant of label encoding, mean encoding, in that you just take the mean. So probably you observe your data set, right? So how many female do I have? What was the mean of female? So you use that as the so let's assume you have the mean female is, let's say, 50, and the mean male is 45. So you use that. So this will be 50, this will be 45. So that was mean encoding. Or you can just come here. We did that earlier. So to use mean encoding, you can use these values instead. So I'm going back to this. Yeah. So you can just use these values for your encoding. So let me look for the one that has female and male. Yeah, here. So you can encode female as 0.742038, and male becomes 0.11, 0.188908. So this is mean encoding. Do you understand?
Sorry, Larry. What informs when to use which? I mean, how do we decide?
When to use?
Yes, exactly. So
when to use mean encoding?
Exactly. When do I go for one icon, one icon? When do I go for the other one?
Basically, like what I use is one hot. Like I just like using one hot encoding. But the way I do it is that I first use one hot encoding. I'll train and get an accuracy. Then I'll use label encoding, train, get accuracy. I'll use mean encoding and train also and get an accuracy. Then I'll compare it. So which one is better? But basically, one hot encoding is actually better. But in the case where you have a high correlation, let's say you do this here now, and you see something like this. Yeah, you see something like this. Like you're saying that female has more, right? And male has like 0 point. So you can use mean encoding for this. But when there is no when it is just maybe female is 0.001 0.3 something, male is 0.2 something, like one part encoding will work better. But in this case that you have, female has more and male has, less. So you can use label encoding or mean encoding for this. So in this case now, if I give more weight to the female, like it is justifiable, right? Like giving more weight, like doing a label encoding in which the female has more value than the male, like it's okay because actually here female has 0.74 and male has 0.1.
Sorry. Does that mean that when you use the one called encoding and you use the logistic convention, it's not going to affect it as it will do on the label encoding?
Basically, for me, one part encoding has always worked better than either label encoding or mean encoding. Like one part encoding has always worked better for me.
It's just a matter of the one that works best.
Yeah, like to use mean encoding or to use label encoding, you still have to come here and try to figure out this, and they will even give you relatively the same results. Like if you do them well, they will give you the same result as one part encoding will give you. Like if you don't do them well, they won't give you good results, and one part encoding will always give you a better result. Like from my experience, like so where were we? I'm here, right? Yeah. Okay. Okay, so these, label encoding. So where is it? Okay, so this is it here now. So it has done label encoding for this. So this is male, this is female. So we'll still work on this guy. Like what you are feeding into your model should have only numbers. You get, so you can't feed this into your model because of this. You can't feed this into your model. So we have to do label encoding for this also. Or you can do one part encoding. But I think you use label encoding. Yeah, same thing. Sorry. Okay, remember that age has missing values. Age has missing values, and I think Embark also has missing values. Okay, so completing a numerical continuous feature. Now we should start estimating and completing features with missing or null values. So we know that age has missing values, so we have to complete that. And one way to fill in missing values is just to replace the missing value by the median or the mean. So I think you use the median. So you can use the mean. So for age now, you can just find the average age and just use that. Just replace those nons, those missing values with the average age. Or you can use the median and replace those missing values with the median. I don't know what he's doing now. What else? What's this? So this is age. So I assume he has done his magic. And he has replaced the missing values. So let me, like, how do you create a cell?
I think age was when it was in float.
Float, right?
Float of this, I don't know. Maybe he has made it like
Yeah, I think he has done that. So you can go through this code, like, yeah, see it here, int. So you can go through the code to figure out what he did. I can see dot median here. I can see sex, I can see p class. I don't know where he's going. But he explained it up here. He explained everything up here. He explained everything up here. So you can just create that on your own. Like how do you open a cell? You create a new cell. You said?
That was inside code.
This one?
Yeah. Inside code.
This one?
Those, yeah, up or down.
Okay. Okay. So let me just, can you all see this? Or do I need to still magnify? Where's the code cell like this? Okay, I think it's here. Okay. Okay, so what do I want to do now? Okay. I want to, so like he has filled the missing values for age, right? So let me check. Okay, so age now has 891 unique values. 891 non-null values. So it was float initially, so he has converted it to int. Then one other thing he did was to create age bands, right? So he created bands for age. So he categorized age. So from numeric to categories. That's another thing. So these are now, wait, I'm seeing minus 0 points. Okay, these are now age bands, right? Ranging from 16 to 80. So these, yeah? Just give me 5 minutes. Let me just round up. Okay, so, yeah? Okay, this is the age band, right? So the ages are now in categories now. So from this to 16, from 16 to this, from this to this, like that. So then he did label and coding again for age. That's 1, 2, 3. So those less than 16 become 0, greater than 16, less than 32 become 1. So we have 0, 1, 2, 3.
Okay. That's the level 4.
Okay. 0 out.
What's it?
But
Coding part.
alright.
Wow. Yeah?
What is the logic behind all this coding
Hey, good question. He has not become.
You said what's the logic behind
Newcomer.
behind encoding?
No, and as in, you know, he's trying to encode everything to be between, as in, just to bring down the value.
Is it for age?
No,
Is it for
all,
age?
you can, well, if you look at the data now, you'll be seeing 0, 1, 2,
Okay, 0, 1, oh. Okay. Like what you want to do is like you have categorical features. When you have a categorical feature that is not ordinal, that is just
I understand that.
understand all that.
Okay, what about age now? Put it in age band after then outputting it in
That's what he wants to do. Like normally, what I would have done, like I would have used the age as it is. Then I'll do something called feature scaling and normalization. So I'm going to normalize that age. Like I will normalize everything to be between maybe minus 0.3 to 0.3 or so. That's what I would have done, but he is not doing that. So this is his own style. Okay, then you do this. So what's this one? Okay. Okay, it dropped age band. Okay. No, like. So this is age band now. So age band is actually it's actually like it's not classifying the age it's just like you are turning a numerical feature into a categorical feature. So you are now getting categories, right? So age band. So after doing that, is now storing this is like it did label encoding for the categories, then it got rid of the age band. Okay, so you have this age band is gone. Then create new feature combining existing feature. So this is on EDA, exploratory data analysis. So let me just run through everything. So you can read it up when you are free. No, you can ask him. It's a kernel. You can comment underneath. Ask the author. Like, he will reply. Serious. Okay, so what is this? Okay, age class. So it's now doing feature engineering, like
your code is misbehaving.
It's misbehaving, right? Because I'm seeing zeros out.
Yes, it's different.
Okay, yours is working fine.
Yes.
Imagine. Okay. Then just commit. Okay. Like, how do you run from the beginning? I don't understand it. How do you run all these cells from the? Is it from here?
Yes.
What has happened? Let's use this. Okay, let's just cut the long stories short and let us use the original kernel. Okay, so this is the kernel here. So we just go down and see what it did finally. Okay, still loading. this is the okay. So after doing everything, you now like he created title feature, added age times class, added family and everything. So he now has this is now a feature matrix now, right? Unlike the raw data we had that had so many strings in the categorical feature which you can pass into your model. So this does not have any missing value and it doesn't have any string. So everything here is a number. So you can pass this into your model. So you can see this. So we got this by doing exploratory data analysis, which was everything we've been doing since. So what we've been doing in class here is just to present, like we've been presenting you with a data like this, right? And this is what we've been training on before, like CodeLab, former CodeLab. Like we've been training on an already processed data, like which has no missing value. Like everything was a number, like we had it as it is. But now we needed to perform exploratory data analysis in order to arrive here. So having the data set as it is now, we can now build our model. So the first model we built was a logistic regression model. Then he went to KNN. He did support vector machines, naive Bayes, decision trees, random forest, perceptron, ENN, then RVM.
I want to ask the question.
Yeah, this is just a kernel. Like if you check the data board, you see one. Him. Did this one? Wait, let me check.
So for him to do it, it might be a stuff.
Oh, are you sure? Let me see. 7.
No.
No, it's second now.
It's second.
Okay.
Is that not
No,
the-
that's not minus second.
Okay, it's not there now. We even have our man here. Nice. And I'm not real. The models. No, wait. It's just for educational purpose. Like,
Lawrence, as we have a problem, how will you know the data, the model you use for your data? Like
the model?
Yes.
It depends on the problem now. Like this now, this is binary classification, right? So you can use logistic regression. In fact, just like if you have any binary classification problem, the first model is logistic regression. Like that should be your baseline model. Is it? Oh, just one submission, right? Recently. Nice. Let me see if I can find them.
Check 1,000 or something.
Check 480.
Taking time. Okay, so I think he used scikit-learn. So here now, he got his train data and test data. So he did trains. No, he has not split. No, he didn't even split them. Okay. So this is the train data and this is the test data. So this is the actual test data from cargo. Anyway.
Can you now say he has dropped the passenger ID?
Yeah, passenger ID for the test. Then this is how easy it is to build a model with scikit-learn. Yeah, so this is logistic regression, right? So all you need is to get logistic regression from scikit-learn, and then you fit it, and you predict, and that's all. And you are done. You said? What's backlog?
This is all the sigmoid used to write.
Sigmoid. They're actually in here, like everything is inside this fit method. This fit method will do gradient descent, to do everything. Updates, parameter updates, everything. Then this influence. So you don't need to implement cost function, you don't need to implement gradient descent, you don't need. So you just call dot fit, pass in your feature matrix, and pass in your target values. So you got 80%.
Is it accuracy?
Yeah, accuracy.
Which is okay.
Yeah, it's okay.
You can still.
But here,
You can still.
okay, this thing has frozen. Like I tried to load the other examples. So the other guy is like number one. Okay, so logistic regression gave 80%. Then, okay, there's something called correlation. So
are you going to remove the negative coefficient?
No.
Like, they are not correlating. Don't remove it. But I've seen it somewhere before.
I don't know what it is. Okay, so it did support vector machines. So all you need to do support vector machines is SVC. So you use SVC, then you call dot fit, do dot predict, then get your accuracy. Then you went ahead to use KNN. So this is K nearest neighbor. So you are using 3 neighbors. Then you do dot fit, do dot predict. And this one gave 84. This one gave 83.
Well, they're the same rate.
Naive base gave 72. Okay. So this is naive base. Then perceptron gave 78. Linear SVC 79. Which one is this? What's SDD classifier?
Stochastic gradient descent.
77. Decision trees, yeah, the best. Then random forest, 86. And that's all. Then this random forest was the best. Like mostly, like the cargo competitions I've competed in, I use random forest.
Can you try Kiara?
K.
Ara.
What's that? I don't know what that is. Okay. Then he made a submission. So all you need to do to make a submission is to create a data frame that will contain, like you just observe your submission file, like how your submission should look like. So you create a data frame that will look exactly like the submission file. So from the submission file, you have passenger ID and you have survived, and you know what the passenger ID is, and you also know what survived is, which is your prediction, like you predicted. So you use this to form a submission data frame. Then you call to CSV on that data frame. So what to CSV does is to create a file, a CSV file that will contain this data frame. Like it will contain 2 columns, this, and the values. And this is what you submit to cargo. And that's that. So it was like our submission to the cargo site, to the competition site cargo results in scoring this of this. So competition entries. This result is indicative while the competition is running. So this was actually what I submitted. You guys, so this is my own submission. And that's that. So thank you very much So I assume that there's no question at all. So let's go for quiz.
We'll ask you questions.
Yeah. Thank you.
So that we'll go and look at it.